Hi there, my name is Scott Covert, and today I will be discussing Queueable Apex for performing asynchronous logic on the Salesforce platform. For those of you who don't know me, I co-organize the DC Salesforce developer group, and I've been developing on the Salesforce platform since 2010. So first I want to take a look back at the @future method, previously the de facto method for running asynchronous logic on the platform. So essentially, applying the @future annotation allows any method to be run asynchronously. A very popular use case for this would be making a call out from within a trigger context, or performing a call out after a DML statement, which is not allowed by the platform. It allows you to kick off long-running processes asynchronously, which prevents CPU timeout. But there are some limitations. So first of all, there's no chaining. You can't have an @future method call another @future method. Furthermore, parameters can only be instances and collections of primitive types. You're not allowed to pass S objects. And that makes sense, right? Because the problem is if you're passing S objects to a method that's run asynchronously, then Salesforce can't guarantee that S object or those S objects haven't changed when the process actually fires. Also, since we're on a multi-tenant platform, the @future methods are run whenever resources become available, and thus you lose control over the execution order. Even if technically you've queued up an @future method prior to another one, that doesn't necessarily mean it's going to run first. But there is a workaround that has been pretty popular over the past few years, originally developed by Dan Appelman in his book Advanced Apex Programming. I would also recommend going out and watching some of his Dreamforce 2013 session videos on the topic. He gave some great talks on asynchronous Apex as well as concurrency that year. So this was kind of the old way of getting around that problem. It was referred to as kind of scheduler ping-pong, where through a self-aborting scheduled Apex class, you could bounce between scheduled Apex and a running batch job. And the very last thing the batch job would do is restart the scheduled Apex process. So you kind of have this back and forth between scheduled and batch and scheduled and batch. Technically, and you can see these are some slides taken from the Dreamforce session I previously mentioned. You can technically also apply this method to schedule future. But as Dan noted in his talk, there are some problems with burning through your governor limits with this method, and also, as we'll see later, there are some concurrency issues. So he preferred the schedule batch approach. Now this worked great. You could get around a lot of limits regarding @future calls. For instance, the no more than 10 future calls being performed in a single execution context. And basically the way it worked was you'd essentially create your own queue of asynchronous requests through a custom object. So the process then would be when you have some asynchronous process that needs to be run, the logic in your trigger or Visualforce controller would insert one of these async request records that contained information on what needed to be done. And then it would start off this scheduled batch chain. And the scheduled batch chain basically would continue to call itself until there were no longer any more records left in the queue to be processed. So in that way, you basically be able to get around the unknown execution order as well, because since these are just records that live on the database, when your scheduled batch process begins, you could just search for the earliest scheduled job. Previously, this was kind of the best workaround for getting more control over asynchronous Apex. But in winter 2015, Salesforce released Queueable Apex. And with the Queueable Apex interface, the scheduler ping-pong method has become obsolete. You can do all the same things that you can with schedule batch in Queueable Apex natively, um, and you can actually do a lot more too. Furthermore, in an effort to further promote the adoption of Queueable Apex over the self-aborting jobs approach in scheduler batch ping pong, Salesforce actually slowed down the process of chaining scheduled and batch jobs so that each link in the chain requires at least 5 minutes to be processed. So um, your hands are almost tied and moving to Queueable Apex at this point if you're trying to have more control over asynchronous Apex. Okay, so even with using Queueable Apex to run your asynchronous logic, there are some limitations. Um, First of all, each queued Apex call counts against a shared governor limit, which is calculated over a rolling 24-hour period, and I believe at this point it is 250,000 or 200 times the number of users in your org. You can also enqueue only 50 queued Apex jobs in a single transaction. Only one job can be added to the queue via queued Apex, right? So you can't have one job chaining off multiple times. And originally, when Queueable Apex was released in winter 2015, you could actually only chain once. And then after that, you would have an exception thrown. But with spring of 2015, this limit was lifted. But regardless, I'm going to show you why none of these limitations really apply to us. So basically, like I said, although Queueable Apex calls count against the shared governor limit, this limit is extremely high, and I've not come across a use case where an org is in danger of hitting it. So I think this can be safely avoided, and regardless, any @future method calls also count against it. So it's not like you're losing anything by utilizing Queueable Apex. You can enqueue 50 queued Apex jobs in a single transaction, but really the method we're going to use today, you should really only have to do this once anyways. And we're going to kind of take a page out of Dan Appleman's playbook and just insert async request records, and then at the end of our transaction, kick off a single Queueable Apex chain. And again, this chain, similar to the scheduler batch ping pong, is just going to keep restarting itself. So the fact that only one job can be added to the queue by queued Apex is irrelevant because that's really all we need. We just want to keep restarting. So basically, that's how we're going to keep the chain going, is have queued Apex execute the async request records. Then at the end of the process, we're going to asynchronously start another chain job. And the reason for doing it, restarting the chain asynchronously, is because if you perform a call out, you're actually not able to chain another job. But if you make the method that restarts the job asynchronous, then you can get around that. Okay, so let's take a look at some code here. Okay, so first I have an Apex class that implements the Queueable interface and also allows callouts. Now you can see that this class doesn't seem to do much, and that is because it has been written with the use case of a managed package in mind, where any class that implements a Queueable interface similar to the scheduler interface, or schedulable interface rather, gets locked down from further edits. So instead of having the logic live in the class that technically implements the interface, we have a second class, a handler class. And our original Queueable Apex class really just utilizes reflection to instantiate our handler class. So in our handler class is where our true logic lives. And you'll see that basically in our execute method, the first thing we do is check and see if we have something called the kill switch enabled. So this source is actually part of a larger development framework, also based on concepts from Dan Appleman's Advanced Apex programming book. So some of this is in reference to the framework at large. So for instance, there's a kill switch that's run off of a custom metadata type for application configuration. And so if it's enabled, then obviously we don't want any of our logic to be run. So if the kill switch is enabled, I actually just flush the queue of asynchronous requests and delete all those records so that they won't be processed. But let's assume that it's not enabled, in which case basically the first step to do is query like we would any other SQL query this async request record and find the earliest scheduled asynchronous job. If we don't have any, then we're done, right? So this must be the last link in our Queueable Apex chain, and we've finished running through all of our async request records. If we do have some, though, what we need to do is actually query again, this time using the for update clause to prevent concurrency. So basically, you can imagine all these asynchronous threads running at once based on different users saving records that cause triggers to fire, etc. And so it's technically possible that two of these jobs could be running at once and both return the same async request record. And we wouldn't want to perform the call out twice by mistake, right? So what the for update query does, or annotation does in our SQL query, is makes sure that our query has pessimistic locking. And the reason why, unfortunately, I have to repeat the SQL query here is because the order by clause is not possible within a for update query. So thus the kind of redundant hit to our database. And again, since now there's a possibility that when applied under the context of a pessimistic lock, we might actually not have any more records to process. We check again to make sure that the queue isn't empty. And if it's not, then we go ahead and process that earliest scheduled asynchronous request. One other thing to note here is all this logic that we've seen so far is in a try-catch. The reason being, first of all, we could hit some sort of runtime execution error while we're actually processing our async request record, right? Like perhaps the logic that is to be done asynchronously in and of itself has a bug. And we want to catch that exception. And the other possibility is with pessimistic locking, there is the possibility of a timeout error, where basically if there is a second thread utilizing the same record that's preventing this thread from continuing forward, there will be a timeout eventually reached while it waits. So we want to catch either of those. In either of those cases, we want to catch the exception, because then what we can do is basically leave the async request record in the queue, and then when the job is rechained, it should try once again to process. In the case of a record lock error, of course, what probably is happening is the other thread is processing the async request record, and as we'll see, after the process is run, the async request records themselves are deleted. So most likely, if we're getting an exception thrown from pessimistic locking, it's probably going to not even matter, because on the next go around, that async request record will be gone. So just to touch on that further, we have our queue of async request records, and once they're processed, we want to remove them from the queue, i.e. delete them from the database, right? So that's what this process is doing right here. Now, in the event of a failure, we at least would like to log that this async request record was attempted to be processed, right? So we're going to either delete it from the database, or if there's been some sort of an issue, we're going to increment a counter of the amount of times it's been attempted. And if this number is equal to or greater than the maximum attempts that the job should be processed under, then we're going to go ahead and abort. And you'll see up at the original SQL query here, I'm looking only for async request records that have not been aborted. Okay, and again, so the last process here in our Queueable Apex job is to chain the job. And like I said before, chaining the job in and of itself utilizes the @feature annotation simply because if queued Apex performs a callout, it's not able to enqueue another job. So that's the workaround to that is just making the process of chaining the job asynchronous in and of itself. All of that source that we just saw is online in a gist. It's also available as part of the larger centralized development framework that I've been working on for Apex. And this presentation itself is on GitHub. The source can be pulled down for running the presentation locally, and it's also available to be run on GitHub.io. So thanks very much for joining me to learn about Queueable Apex.